Elon Musk could potentially transform the United States into a hundreds of billions of dollars industrial powerhouse built around a network of enormous factories. From Terafab, which could become one of the world's largest chip manufacturing facilities, to a new Optimus robot factory designed to produce millions of robots each year, along with multiple lithium battery and electric vehicle plants. The scale is enormous. And now, Elon Musk is reportedly planning to build the biggest solar manufacturing facility in the United States, and possibly even one of the largest in the world. The target is 100 gigawatts of annual production capacity. That figure is so massive that it is difficult to compare with the current size of the US solar industry. To understand just how large that number is, the entire United States currently has roughly 74 gigawatts of solar module manufacturing capacity. Tesla is talking about a single facility that could potentially produce more solar equipment than the country's entire existing manufacturing capacity combined. And this isn't simply an idea Elon Musk casually mentioned on stage and then abandoned. Tesla has reportedly submitted plans for a huge solar manufacturing project in Fort Bend County, Texas, around 40 minutes from Houston. The project's internal name is Project Crystal Sun, which sounds more like a military mission than a solar panel factory, but the numbers described in the filings are very real. The proposed investment could total around $10.1 billion. The project is expected to generate approximately 9,712 permanent full-time jobs, along with more than 10,000 construction positions during the busiest period of development. Construction is expected to start in late 2026, with completion targeted for 2028, while commercial operations could begin as early as the first quarter of 2029. If everything moves according to plan, Tesla could enter solar manufacturing within only a few years at a scale that very few companies in America could currently compete with. What's even more interesting is that Tesla apparently doesn't want to simply construct a factory that imports solar cells from Asia, puts them inside aluminum frames, and adds the Tesla logo. The company reportedly wants to control nearly the entire manufacturing chain. Project documents describe production lines for manufacturing silicon ingots, slicing those ingots into wafers, turning the wafers into photovoltaic cells, and finally assembling those cells into complete solar modules. In other words, Tesla appears to be pursuing a vertically integrated production system where materials can move through almost the entire manufacturing process and come out the other side as finished solar panels ready to produce electricity. That is what makes Project Crystal Sun so significant. A large part of the global solar supply chain currently relies on China, especially for upstream manufacturing such as wafers and solar cells. Tesla appears to be attempting to bring as many of those stages back into the United States as possible. If the company succeeds, Tesla wouldn't simply be producing solar panels. It would control a major portion of the process that transforms silicon into a finished electricity-generating product. That could potentially give Tesla a major advantage in manufacturing costs, supply security, and the ability to expand production rapidly in the future. And then we have to return to that 100 gigawatt figure, because this is where the plan becomes almost unbelievable. First Solar, one of the largest solar manufacturers in the United States, is expected to reach roughly 17.7 gigawatts of manufacturing capacity by 2027. Tesla is targeting 100 gigawatts, which would be nearly 6 times the capacity of one of the biggest manufacturers in the US market. In all of 2023, the United States installed approximately 32 gigawatts of solar power. Tesla is talking about a single manufacturing operation capable of producing an amount of solar equipment equal to more than 3 times what the entire country installed in 1 year. And the remarkable part is that Tesla wouldn't even need to achieve the full 100 gigawatt target for the project to become enormous. Even reaching 50 gigawatts could potentially be enough to make Tesla the largest solar manufacturer in the United States. At only 20 gigawatts, the company could still immediately become one of the industry's major players. So the real question isn't whether Tesla will reach exactly 100 gigawatts. The bigger question is what operating at even a significant percentage of that capacity could do to the American solar market. But this is also where the story becomes much more uncertain. Tesla isn't a solar company with a perfect history that is simply expanding by opening another factory. In fact, the company has already experienced one of its most highly publicized setbacks in the solar industry. A few years ago, Tesla believed the future of solar energy wasn't conventional solar panels. Instead, the company pursued something far more ambitious, the solar roof. Back in 2016, Elon Musk introduced glass roofing tiles with integrated photovoltaic cells, presenting a very appealing concept. Rather than constructing a traditional roof and then installing large solar panels on top, why not turn the roof itself into a system that generates electricity? The tiles could look almost identical to traditional roofing materials while still protecting the house from rain and sunlight, and quietly producing electricity at the same time. Musk even suggested that, over the long term, solar roof could become more economical than replacing a roof in the traditional way and then installing a separate solar system. On stage, the concept looked almost flawless. In the real world, however, it turned into a much more complicated challenge. Solar roof tiles were expensive to manufacture. Installation was highly labor-intensive, and every house came with its own unique configuration. While the broader solar industry was moving towards standardization to reduce costs, Tesla had effectively created a product that required even more customization. Large solar panels can be mass-produced, transported in huge quantities, and installed using standardized procedures. Solar roof, by comparison, turned almost every individual house into its own custom project. By 2021, those problems were becoming increasingly visible. Some customers experienced major increases in their contract prices after already signing agreements. In certain cases, reported quotes climbed from around $72,000 to nearly $146,000, almost doubling the original amount. The disputes that followed eventually resulted in a class action settlement worth approximately $6 million. But the price problem wasn't even the biggest issue. Elon Musk had previously suggested that Tesla could eventually reach a production rate of 1,000 solar roof installations every week. According to estimates from Wood Mackenzie, one of the world's major energy research and consulting firms, the actual peak production rate was only around 21 to 32 roofs per week. Overall, only around 3,000 solar roof installations are estimated to have ever been produced. Today, the glass solar roof tiles reportedly can no longer be ordered through Tesla-certified installers, while Tesla's product page has shifted its attention back toward conventional solar panels. Simply put, solar roof did not become the future Musk had originally imagined. But perhaps that failure is exactly the lesson that eventually led Tesla toward Project Crystal Sun. The issue wasn't that solar power didn't work. The problem may have been that Tesla attempted to make solar technology far too complicated. Solar roof was created to make solar power more attractive, more advanced, and more deeply integrated into a building's architecture. Meanwhile, the market was rewarding almost the opposite: standardized products, enormous production facilities, increased automation, and lower prices. Tesla once attempted to create a completely different kind of solar product that almost nobody else was making. Now, it appears the company may be aiming to manufacture something the world already uses, but at a scale that very few competitors could match. And the timing could hardly be better. Over the past 50 years, solar module prices have fallen at a rate that is almost unmatched across the energy industry. According to data cited by renewable energy expert Ray Wills, solar module prices have declined by roughly 10,000 times over the last half-century. More importantly, that price reduction didn't happen randomly. Solar power has followed a remarkably consistent learning curve. Each time the total amount of solar capacity installed worldwide doubles, costs decline by roughly 20%. That creates an extremely powerful feedback loop. The more solar systems are produced, the more manufacturers learn to make them efficiently. As prices decline, demand grows. Higher demand encourages factories to expand. As factories become larger, they can introduce more automation, improve supply chains, increase efficiency, and continue lowering costs. Every new generation of solar capacity is essentially helping make the next generation less expensive. That is one reason solar power has developed so differently from many traditional energy sources. If you want to produce more electricity from coal, you need to extract more coal. If you want more electricity from natural gas, you need to continue extracting, transporting, and burning more gas. With solar, most of the expense is concentrated in producing and installing the hardware upfront. After that, the fuel comes from the sky for free. As the hardware becomes cheaper, the overall economics become increasingly attractive. And as battery storage prices continue to decline, solar's biggest limitation, the fact that it cannot generate electricity at night, is also beginning to be addressed. That is why Tesla's return to solar at this particular point in time may not be accidental. If one of the world's fastest-growing energy sources is becoming progressively cheaper, the question for Tesla may no longer be whether it should participate in the industry. The more logical question could be why allow other companies to control most of the manufacturing, especially when Tesla is preparing to move deeper into industries that could require enormous amounts of electricity. And that industry is artificial intelligence. Elon Musk has repeatedly argued that one of the major limitations on the AI boom may not be the number of chips available, but the huge amount of electricity required to operate them. Massive computing clusters need a continuous supply of power. New data centers must connect to the electrical grid, while future factories, robots, and autonomous systems will create even more demand for energy. If Tesla truly believes AI will become one of the company's central pillars over the next decade, simply purchasing electricity from the market may no longer be enough. Tesla already has Powerwall. It has Megapack. The company is expanding large-scale battery storage capacity in Texas. And now it could be looking to control the equipment that generates electricity before that power ever reaches those batteries. From that perspective, Project Crystal Sun begins to look like much more than a basic solar panel factory. It could potentially become one component of a much larger system where Tesla generates electricity, stores that electricity, and eventually uses it to power its factories, AI data centers, robots, and broader product ecosystem. And if that really is the strategy, then 100 gigawatts is no longer simply an impressive production target. It could be the first indication that Tesla is attempting to build something far larger than an electric vehicle company. But now we want to hear from you. Do you think Tesla can realistically build a 100 gigawatt solar manufacturing operation? Or could this become another ambitious Musk project that sounds far more impressive on paper than it does in reality? Let us know what you think in the comments. If you enjoyed this breakdown, make sure to like the video and subscribe for more deep dives into the engineering, technology, and massive industrial projects shaping Tesla's future. Thanks for watching, and I'll see you in the next one.